Okay, so the next thing we're going to talk about is, like I said, I was just going to go through everything that we're going to learn from chapters 5 and 6. So here's a list of everything. I'm just going to just do a bunch of examples, and then then in the lecture, and then you guys get to go home. But the next class, I'll actually talk about I'll go through the PowerPoints for each one. But I just wanted to get it all out there at one time. That way if for those that want to work ahead, they'll feel comfortable using a lot of these things. So the first one is conditional operators. So conditional operators are basically just ways to check for equality or greater than, less than, not equals to, those types of things. There's also logical operators, and I'll demo all of them with the use of the if condition. Okay, the if condition, why am I saving this? I don't know, sorry, it's a habit of saving everything. All right, so with the if condition, what that's going to do is it's going to execute a code statement if a condition is true. Okay, then you have the if else. It's going to execute a code statement if a condition is true. If it's not true, it's going to execute another code statement. I'm going to go ahead and demo these first three things with a few examples. So I'm going to hop over to Notepad++. All right, and I'm going to create a new file, and I'm going to save it I need to create a new folder. All right, I'm going to create a new folder called Chapter 5 and 6. I'm just going to combine them together because it kind of just talks about the same thing, I think. All right, so the first one, I'll just say if demo 1. Copy that, and I'm going to come over here and save it. All right, so I'm going to start off with public class if demo 1 open close curly braces, and then my main method public static void main string array arguments open close curly braces. Okay, so the if statement, I'm not going to prompt the user for any information, but if I did, let's just say I prompted the user for a number and he entered the number 7, and I want to tell the user, hey, that number is greater than 0, or it's odd or even or something like that. I can do such a thing by using an if statement. Okay, so the first thing I want to tell the user is if their number is positive or negative. So I'll say if the number that the user entered is less than 0, then I'll tell the user system.out.println the number you entered is negative. Okay. All right, and then I'm just so I know that I'm at the end of the program, at the very last line of anything that I type in, I'm going to say something end of program. All right, I'm going to go ahead and save that, compile, and then run. And then you can see that they entered in 7, so the program ended, meaning that this statement didn't even get called at all. So what happened was Java saw this, or you put a value inside this number, then Java compared that number to 0, right? It checked to see if it was less than 0. It wasn't less than 0, so this statement did not get executed at all. It just just bypassed that statement. Now, if I were to come over here and enter in a negative number, like just negative 89, I save it, compile, run. Now you can see that we do know that the number is negative, so then we output the value that the number is negative. Okay. Now the else case, we could come up with an else case. So the else for this would be that the number is not negative. Number you entered is not negative. Okay. So if I were to compile and run, right, the number you entered is negative, and that's because they have a negative 89. But if they were to enter a 9, compile, run, the number you entered is not negative. All right, pretty straightforward. Okay, you have your condition. If it's true, execute this statement. If it's not true, it will execute this statement. You don't necessarily need an else case. It's fine. It works just as fine like that. But if for some reason you wanted to execute some other statement If the condition was not true, then you would put an else case there. Now you can attach another condition to this construct, and the way you do that is by using the else if. So we're going to come over here, I'm going to insert else if, have some condition, open curly brace, close curly brace, and I'm going to, so now there's three things that can get executed. If the number is less than 0, it's going to be a negative number. If the number is greater than 0, then we can say that the number is positive. The number you entered is positive. Okay, and then everything else, what do we know about the number? If the first two conditions aren't true, then we know the number is 0. Does everybody agree with that? All right, because either you're positive, negative, or you're nothing, right? So the number you entered is 0. All right, so I'm going to compile, going to run. The number you entered is positive, so it knew that it was greater than 0. Okay, I'm going to change this to a negative 12. I'm going to compile, run, and then you can see that the number you entered is negative. You knew that it was negative, and then I'm going to test the case where the number is 0, compile, run, the number you entered is 0. Okay, that's the way this works. Now, this is what we call conditional operators. So they're actually doing some type of evaluation check. There's multiple of them. We're going to learn all three of them when we get into the lecture, but I'm going to go ahead and just write them all out right here so you can understand what they do. So the first one is equality, okay? So this is what we call equality. Notice it's two equal signs. Checks if data types okay, now one other important thing is only works on primitive data types. Only if you use the equals operator, then it's going to do like check to see on objects. It's going to check to see if there's the same object in memory. So I'm going to say only works on primitive data types. All right. So you have equality. You have not equals. This is what we call the not equals. Okay, and that's going to check if the data types are not equal. All right, and then you have the less than, the greater than, the less than or equal to, the greater than or equal to. So this is less than, this is greater than, this is less than or equal to, and this is greater than or equals. Okay, and they're self-explanatory. I'm not going to write out like what they actually do, but right. So if the value on one side is less than the value on the other side, then it's going to be true, right? Just checks to see if it's less than. If the value on this side is greater than the value on this side, then it's going to return that it's greater than, right? It's going to return true if it's greater than. And then you also can add an equal sign to that and then check for equality as well. Okay, so the one that I used was just straight less than and greater than. Pretty straightforward, okay? All right, so let's, how would did anybody have an idea of how I would check to see if the number is odd or even? Like how can I determine if the number entered is an odd number or an even number? Yes.
Could you do something with like integers and divided by 2?
Yeah, exactly. Right. So we have this cool thing called the remainder symbol. Remember that percent sign? Like it's going to keep coming back to haunt you. Right. So keep that in mind. And it's like checking to see if something's odd or even is actually something that's done a lot. So a really simple way to do that is if you just get your number, if you divide it by 2 and the remainder is 0, then you know that you have an even number, right? Does everybody agree with that? Okay. So I can say something like system.out.println the number you entered is even. Okay, and then the else case here would just be that the number is odd. All right, pretty straightforward. So I'm going to go ahead and compile this and run it. And let's look at the results. So it says the number I entered is even. If I look at the number that I entered, I don't even remember what I entered. 0, right? Is 0 even? Yeah, it is, right? Because it can be divided evenly, which is, well, I don't know. I guess that's really a question for math people. Can something be divided if it's 0? I don't know. But I know like 2 people will get the same thing, right? So I don't really know what positive and negative mean now. God, I'm so confused. I'm gonna have to take like a math theory class now. Or maybe I could just Google it. That might be cheaper. All right, but anyways, I don't have time to Google that. So I'm gonna assume that 0 can be even. I don't know. It is even? Okay, so that means there's either number is even or it's odd. Well, integers anyway, because if it was a fraction, then, yeah. Anyways, I don't want to think about that. Okay, so if I put in a 7 here, save, compile, run, then you can see that it knows that the number is odd. Okay, any questions on that? I mean, it's pretty straightforward, right? You just have some condition check. Now you can have, like you don't necessarily need to use operators to determine if you should do something or not. You could use Booleans to do that as well, right? So just say if, I don't know, I have a Boolean value up here, and the Boolean value is just whether you want to end the program, right? So if you're going to end the program, then you somehow you do some logic to figure out if you're going to end the program, and maybe you want to output some nice message to them if they're going to end the program. So you could say something like, in program, if that is true, then what you're going to do is just say system.out.println, and then I'll say something like you chose not, or you chose to end the program, right? And then I'll just say, maybe like tell them goodbye. Okay, so all these expressions in here, they all evaluate to a Boolean value, whether it's true or whether it's false, right? So we can also control a condition by just using a Boolean data type, right? So if that is set to true, then we're going to print out you chose to end the program and then hit goodbye. Even though they're not really choosing anything, I'm hard coding these values. Hope that doesn't confuse anybody. So I'm going to compile and run. Okay, and you can see that I chose to end the program, goodbye. If I came over here and I set this Boolean value to false, then that statement will not be executed, so you will not get that nice message, right? I just say end the program, all right? I could come over here and do an else case, like you chose to continue using the program, whatever. It's up to you, whatever you want to decide to do. But you don't necessarily need to use those operators to control the loop. You can also just use a straight Boolean value to control a loop. Or not a loop, these aren't loops, to output statements with a condition. Okay, any questions on that? All right, I'm going to do another example. So I'm going to make a new file, and I'm going to save it as ifdemo2. Here's some say public class ifdemo2, then my main method, my public static void main string array arguments. Okay, so let me think about what I'm going to do. I guess I'll use the numbers again. I'm going to use the num, and I'll use that. Yes.
How would it look if you did hard code the numbers and just like did like an interactive among the user type and some stuff?
So how would that look?
Well, like would it be so too, I mean, I know how it looked, but would it be too long for you to kind of like create?
It wouldn't be too long for me to create, but like I'm more focused on teaching the conditions and stuff. Like you should already know how to prompt the user for data and save that information into a data type, right? Like you just use a scanner class, prompt the user, enter a number, he enters a number, then you save that into like a variable called num or user input or something, and then you'll determine whether you're going to show something with that condition or not. All right, but I'm just trying to avoid doing all that because I kind of feel like that is something that has already been taught, right? Like you should already know how to, like you can use your own imagination and figure out how can I get user data inside of this variable right here. Like how do I get data inside of it? You prompt the user using the scanner class, right? Like enter your number, he enters a number, and then you can do something with that number.
And then whenever that variable is used by the user, then like whenever the if condition, that number that the user entered, that variable would be used for those conditions.
Yeah.
Okay, that makes sense.
All right, I'm going to go ahead and talk about now what we call the logical operators. So there's 3 of them. So logical operators. All right, so you have the and. This is just and. Both conditions must be true. You have the or, which is those lines there, the vertical lines, 2 of them. And this is what we call the or. I guess I should capitalize this. Either condition must be true. All right, and then the last one is what we call the logical not. It just kind of takes the opposite of whatever is there for your condition. So I don't really know how to explain this, but it's only really, I guess, what do you call it? It's a complement of the condition, I guess, if you're going back to terms of math classes or whatever. But we'll just say not, and it basically is the reverse of whatever the condition is. I don't know what to put there. I'm just going to put not, sorry. You can read the book and it can explain it to you. All right, so I'm going to show you how to use the and the or and all that. So first thing is I want to check to see if I have a positive number and the number is even. Then I'm going to print out some statement. Okay, so the way that I do that, if I want to check 2 different conditions, I'll say, okay, is the number greater than 0? If it is, it's positive. And is the number, when it's divided by 2, does it have no remainder? If that is the case, then you can say system.println the num is positive and even, okay? And the else case for this would be, okay, well, both of those conditions did not hold true, right? So then the else case would be it's either negative or odd. The number is negative or odd or both, right? It can be odd and negative, and it's going to help with that value. All right, so I'm going to go ahead and compile this and run it. All right, so it's telling me that 8 is positive and it's even. Okay, that makes sense. What if I made this a 7? It's going to be positive and odd. So now when I compile and run, right, the num is negative or odd or both, okay? If I enter in a -8, compile, run, the num is negative, odd, or both. And then if I enter a -3, which is negative and odd, compile, run, and the num is negative, odd, or both, okay? So the only time that I actually printed out this statement here is when the number was greater than 0 and the number was even, okay? Because I used the and condition here, so that made sure that both actually did occur, okay? Now, if I want to do something with an or, let me think, what can I do with an or? I can say, I'll just do, say, okay, if the num is greater than 100, we'll go 1,000. Or the number if you divide it by 5, it's a factor of 5, right? So I'll say if you divide the number by 5 and there's no remainder, then it's a factor of 5. Then I could say something like this. I could say system.out.println. The number is greater than 1,000, or it is a factor of 5. Okay. All right. And then the else case for this would be if none of those conditions were true. So that just means that both actually had to take place, right? For it to be negative. So here I can say the num is less than, or actually less than or equal to 1,000. Less than, I'm just going to use the symbols. Num is less than or equal to 1,000 and not a factor of 5. Okay, so I'm checking for the OR case here. So if this one's false, then Java's going to check over here to check to see if this one's true, right? So if I enter in a 10, right? So 10 is not greater than 1,000. That's false. So it's going to check to see, well, is 10 divisible by 5, or there's no remainder, and that's actually true. So since this was true, then it's going to execute this statement, right? So where the and, they both had to be true, but for the or, either one of them could be true. So now when I compile and I run, you can see that the number is less than 1,000 and not a factor of 5. That's because the number was -3. But if I gave a number of 25, which is less than 1,000, but is a factor of 5, you can see that it outputs the number is greater than 1,000, or it is a factor of 5. 25 is, in fact, a factor of 5. If I were to compile, actually, let me change this value. Put this to 3,045. If I were to compile and run, actually 3,045 is greater than 1,000 and it's a factor of 5. But what actually happened here was once it saw that it was greater than 1,000, it didn't even bother checking to see this condition. Because since it's an OR case, the first one was already true, and so Java says, I have everything I need to know to execute this statement below. So I went ahead and just executed that statement anyway. It didn't actually check to see if it was a factor of 5. But if I were to change this to 4,001, compile, run, then the same case still happens. The number is greater than 1,000, but is not a factor of 5. And that's because of the same condition where this held true, so it just went ahead and outputted that statement. Okay, any questions on that? I mean, pretty straightforward. I mean, you're just kind of just using those operators to determine whether you're going to output a statement or not, or execute some statements. So the one I did not show is the not, and the not is essentially just the opposite of what the Boolean condition returns. So if you're to put a not on any of these, it's just going to give you the opposite of what it's supposed to return. So for instance, if I came over here, and let me just use a Boolean value to demonstrate this. Say this is my box class again, and I said the box is full. Okay. Then what I'm going to do is, if I wanted to display a message if the box is not full, I can come over here and say, okay, well, if the box is not full, meaning if full is true, then not full would be false. Then I'll come over here and say system.out.println the box is empty. Okay, so I'm gonna compile and run, and you can see that since the box was true, I did not tell them the box was empty because I set this to be true. But if I were to change this to false, right? So now when I compile, run, you can see the box is empty. So this is false. So remember, not full is going to actually check to see if it's equal to false, because it's the opposite. I don't know if that makes sense. So if it's false, then it means it's going to be true, right? So when when full is false, this condition not full is true. Make sense? Okay, and you can actually apply this to like an entire condition. Like I come over here and wrap all this in parentheses, right? I could just take the opposite of this. I don't know why you would want to do this. I mean, really, you should just rewrite this condition. So before I was checking to see if the num is positive and even, this is going to check for the not of that. Meaning if anything inside of here is, if this equates to false, then it's going to be true. So it's the opposite. I know it's confusing, right? So compile, run, and you can see that the num is positive and even, but when I actually look at the actual number, the number is, well, it's positive and even. What the heck? Did that work out like the way I thought? Oh, no, it's odd. I'm sorry. Both of them had to be true. I thought it was even. I thought I saw 4,000. So because it was 4,001, 4,001 is odd. So so this equated to be true. This equated to be false. But on the end, they both have to be true for the whole thing to be true. So this whole thing is false. But then not false makes it true. Okay, so there's a truth table inside of the lecture, which will help clarify some of this stuff. But just know that the not just gives you the opposite of whatever the result is. Okay. Right. I mean, because in some cases, like if you did want to check, to me, the perfect example would be the full. Like you want to tell somebody, hey, your box is empty, right? Before, like, say they're wanting to check out, right? And like you're programming for Amazon or something, but there's nothing in their cart, right? You're going to do a check to say, okay, was their cart empty? If it is empty, say like, hey, there's nothing in your cart. What are you trying to do? You know, like something like that. Or if it was full or had something in it, then you probably wouldn't say anything, right? So like this conditional check here is probably something that's done all the time on the internet. You probably just never realized it, but it's checking to see if you actually place something into some type of container, right? So you're trying to see if it's empty, pretty much, or that value is false. Makes sense, right? Yes. Okay, so let's move on. All right, so let me pop open this. So I talked about all these three things. Makes perfect sense, right? You guys are ready to start doing the homework and finishing up this class? I'm just kidding. But I will go over the lecture slides, so I'm going to go at a slower pace when I go over the lecture slides. Like I said, I just like to shotgun everything out at one time so that I can intimidate some students and they, you know, don't drop the class, but they'll get motivated to be like, all right, I'm going to start learning this, okay? Because these are the last things that we're going to talk about. So you're going to have to know this stuff for the final, okay? So this is what we're going to go over. Okay, the for is actually what we call a loop, okay? So this is actually, I've used this before when I did the characters. When I printed all the chars, remember that? So a for is essentially a while loop, but just, it was created in such a way to where it's easy to make like a statement, or excuse me, a loop that is controlled by an integer value. All right, so it's written in such a way where it can be controlled by an integer value. So I'm gonna go ahead and demo that really quick. And come over here, new file, save as, and I'm gonna call this one for loop demo. And I'm going to save this as a Java file, but I cannot see. Okay, there you go, Java file, save. So public class for loop demo, and then public static void main, oops, misspelled static. Static void main string array arguments, open close curly braces. All right, so the for loop, it's the syntax for it is you have the for, then you have 3 statements inside of these parentheses, and then you have some statement that you're always outputting. And I'll just say something like loop I am in a loop. Okay, now there is 3 statements that are separated by semicolons. So you have what we call I guess I should maybe put comment right here. The first one is initialize. Second one is, let me do a semicolon. Initialize. The second part of the for loop is what we call the condition. The condition actually controls the loop. And the third one would be the incrementation or decrementation. I don't know what to call this one, but we'll just say like control augmentation. I don't know. Does that sound right? I like to throw out big words there just so I can sing a lot smarter than I actually am. So I don't even know if that's the way you spell it. But essentially what that means is in the first part, I'm going to initialize some variable. I'll say variable x. Okay, you declare and initialize it. So I'm going to say variable x is equal to 0. The condition part is, okay, how many times you want this loop to occur, or what's going to be the condition of x for you to remain true. This loop is only going to execute while whatever condition you put in here is true. Okay, so I'm going to say, okay, well, we'll just say while x is less than 10. Okay, and then the control augmentation, I don't actually know what that's called. I'm sure there's probably a simpler word for this. But this is where you increment or decrement, or you don't even have to do any of those. You can multiply by 10 or multiply by 15. Doesn't matter, but you need to change x in some way so that every iteration of this loop, it's being changed and it's not going to just remain the same value. Otherwise, you're going to be stuck in what we call an infinite loop, a loop that just never ends. So I'm going to say for every iteration, we're going to increment x by 1. So that means that x is going to increment by 1 every time this line is executed. And to prove that, I will just output x right here, and I'm going to compile and then run, and then you can look at the result. Okay, so you started off, we said x is equal to 0. While x is less than 10, increment x by 1. So the first pass, x was 0. That's why you had a 0 down here. X got incremented by 1. So now x is 1. It's still less than 10. You kept going in the loop, right? This kept getting bigger and bigger. Finally, at some point, x became 10, all right? And once x was 10, it was no longer less than 10. So that's when your loop actually stopped, okay? If I just said something like, I don't know, you don't have to put anything there. If I didn't put anything there, and if I compiled and I run, then you can see I'm stuck in an infinite loop. It doesn't look like it's moving, but it actually is. You see, when I try to highlight it, okay? And the reason why is because we said x is 0. While x is less than 10, I didn't augment x in any way. I didn't change it in any way. So it's always going to be like less than 10 because I don't change it anywhere. So decrementing would make it appear that it was an infinite loop. Let me see if I can stop this. Control C.
Would it technically eventually overflow?
It would, depending, so I'm not really doing like a super intensive program, right? Like you're just incrementing, like it is using some processing time, but it's not going to fill up your memory because the way Java works is.
But like the number would keep going to the point where it passes the limit of negatives.
Oh yeah, if you decrement, yeah. But the way that I had it before, I wasn't doing anything to x, so that was a true infinite loop. Here, what I'm going to do is instead of incrementing, I'm going to decrement, meaning x is going to be 0, then it's going to be -1, then -2. It's getting further and further away from 10. But at some point, it is actually going to stop, right? And to prove that, if I were to, let me stop this loop. Stop it. Stop it. I don't know if, okay, yeah, just stop. Control C is to stop if you guys ever run into that problem. Okay, if I were to actually make this a byte, you guys remember a byte? A byte can only go up to 127 and -128. So if I were to make it a byte, then I come over here, compile, run. You can see that it keeps going, but it eventually actually stops, right? Because after -128, Java is going to like do the whole around the world thing where it's going to be 127, right? Like you decrement it so much that it flipped to +127. +127 is in fact not less than 10, so then the loop actually stopped. All right, any questions so far?
I didn't understand what that x is less than 10. I didn't know what that was. So is it saying like whenever you increment it, whenever the number is less than 10, it's going to stop?
So the way this works is you initialize x to some value, okay, and then Java is going to check to see if this condition is true. If that condition is true, then it's going to execute this statement. After the statement gets executed, then it's going to do this incrementation step or augmentation step, right? So it's actually not going to check this. It's not actually going to modify x until after the first pass.
It's gonna keep going, so that number, so it's gonna be 1, and then 1 is less than 10. So it's gonna increment again to 2, and 2 is gonna be less than 10. And it's
Right. What actually starts off at 0. After it's done with that, then it's going to be, the next time it's going to be 1, right? It's going to check to see if it's less than 10.
And then that would be x, 1 would be x.
Yeah, or x would be equal to 1. Like, yeah. So, but what do you think will happen if I actually say, you know what, I want x to be, so my condition is, well, x is less than 10, but if I actually set this to 100, anybody know what will happen? It's not going to do anything, right? Because the condition is never true. So I compile, and then I run, and there's my run. It didn't do anything. I should have done the whole end of program thing that I told you guys about. Wait, where was that? Over here. Okay, so compile, run, and because x started off at 100, this never was actually true at any point, so it just didn't execute any of the statements. Okay. So you don't actually need any of those statements inside of the for loop. I don't know why you would ever do that, meaning you can make a for loop with nothing, and it's just always going to be true. Is that true? Actually, I don't know what's going to happen. Now I'm thinking about it. What the heck happens? I'm so confused. I don't even know if this is going to compile. Okay, so I am in a loop. I'll change this to what's going on. We'll just change this to what is going on? Question mark. X no longer exists, so this variable is going to say like cannot find symbol, right? If I were to try to compile, it's going to say cannot find symbol because it doesn't know anything about x because I didn't declare it up here, right? So I have to remove x. Now I'm going to compile. Okay, so it didn't. Okay, so it didn't compile because I do need some condition here. So if I were to put true as my condition, then this should go on forever. Unreachable statement. What is it pointing to? Oh, because this is now unreachable. Dang it. All right. Okay, hold on. Let me put this back to... Okay. Yeah, so it's actually going on forever, never, never. I guess Java was smart enough to know, like, hey, you're never going to get to that statement. Why did you even bother putting it in there? Anyways, you would never really want to do that. Like I said, in most cases, the for loop is actually used to like iterate something over a specific number of times. You don't have to do an increment or decrement. You could just say like, okay, well, x is going to equal to itself times 5. Like just say you wanted to know the multiples of 5, and then we're going to start this off at 1, and then we're going to say while x is less than our highest number for, let me change this back to an integer. Okay, we'll just say we'll go up to 1,000, okay? We're going to set x equal to 1, go up to 1,000, but we're going to increment by factors of 5. So I'm going to compile and run, and then you can see that this was my output. Start off at 1, then 5, then 25, then, or not, when I say factors, what is this called? Like exponents. Yeah, exponential increase. So then 125, and then 625. So if I were to put like 3 more zeros on this, compile, run, right, and it just kept, I got bigger, but it actually stopped it a lot quicker because x is like growing exponentially, so it was able to reach this value a lot sooner. Any questions on that? That is a for loop. Okay, so I'm gonna hop over now to the while and the do while. Both like they're kind of the same thing. I'm gonna explain both of them at the same time. Yeah. All right. So first one is the while loop. Okay. So I'm going to make a new one. All right. New, and then file, save as, and I'll call this one a while loop demo 1. This is a Java file. I'm going to hit save, and then public class while loop demo 1, open close curly braces, then public static void main string array arguments. Okay, and the way this syntax works is while some condition execute this statement. So there's a possibility that this will execute 0 times. So I'm gonna put the execution on this, because this is a test question. Execution is 0 to many, right? Meaning like it may not even execute at all, because it could come over here and say false, right? While false, which is, I don't know why anybody would hard code a Boolean value there, but while false, and then system.out.println, and I'll just say loop in a loop. All right, compile, and it didn't like that unreachable. Oh, it doesn't like that I can't reach the statement. Dang it. Okay, well, what if I just put this true? I hate it when Java tries to outsmart me. All right, run, and then I'm just stuck in this loop. It's infinite loop. Same reason why we got into that infinite loop with the for is that this condition never becomes false. So you're just going over and over and over again. If I were to make some control variable like Boolean end program, and I just set this to false, right? And then I just came over here and kill, compile, God dang it, kill it. All right, compile, run, and it didn't execute any times. I'm running, you can't see it. All right, but if I came over here and said, okay, we'll make this true, then I get locked back into that infinite loop. Okay, that's the way the while loop works. But let me actually demo like an actual decent example of how this would work. So let's see, maybe this time I'll actually use a scanner class. So I'll come over here and I'll say import java.util.scanner, and over here okay, and then I'm going to just say, actually, I totally messed that up. Sorry, my brain wasn't autopilot. All right, I'm going to say scanner, scan is equal to new scanner, and I'm going to read the keyboard. All right, and I'm going to have this control variable there, and then I'm going to say, system.out.println. Would you like to hear a random number or see a random number? I have no idea. Okay, I'm asking the user a question. Okay, I'm going to expect the user to give me a yes or a no. So I'm going to just put like a yes/no. Okay, and what I'm going to do is I'm going to scan the user's input, and if the user's input is equal to if the user input is equal to a y, then I want to go ahead and not in the program, I guess, right? So I'm going to say something like in program would be equal to scan.next.charet 0, right? The very first character. That very first character is equal to y, could say, right? Then I'm going to go ahead and set in program to the opposite of this. I know that doesn't make sense. Or maybe I should just do the no, right? Would you like to hear a number? If they hit no, then I'm not even gonna, like, I'm not gonna read them. Okay, yeah, that makes more sense, okay? So in program, so while we do not want to end the program, I'm going to just generate a random number, and I'll say random number is, and then I'll just come over here, and I'll use the math class to do this. That random times, I don't know, we'll go 0 through 100, okay, or 0 through 99, okay? So I'm going to just output like random numbers, and then I'll ask the user again if he wants to end this program one more time. So I'll come over here and say, would you like to hear a random number? I'm gonna keep asking him and annoying him until finally he just says, you know what, I don't want to hear any more random numbers. And he's gonna put no or put n. All right, so I'm gonna go ahead and compile, and it doesn't like that. What the heck? So, I put equals, hold on, scan.next. Oh, semicolon. I should have read that. Okay, compile. Yeah, no. I was just testing you guys. All right. Okay, I'm going to run this. So would you like to hear a random number? I'm going to start. I like to make sure I can actually exit the loop. I should have put a space after the Y in the end. But I'm going to just put an N for no, press enter, and then it didn't do anything. Right? I'm going to compile. Actually, I didn't need to compile, but I'm going to run it again. And this time I'll hit Y for yes. And random number 0. What the heck? What are the odds of that? Oh, you know what? I did this wrong. Nobody caught me on this. What the heck? So I got to wrap that in parentheses. And while I'm here, I'm going to go ahead and put a space right there. So compile, kill that, and then run. Okay, would you like to hear a random number? And I'll say yes, 69. That was just totally random. Okay. So I hit yes again. I could keep hitting yes, right? It's going to keep telling me like random numbers, right? In the range that I specified. I could be here all day. Now, there is like a bug. I guess not really a bug, but I don't like if I enter in a capital Y, like it's going to actually, no, it's the reverse of that. Like say if I wanted to end and I enter in a capital N, press enter. Like it didn't read the N as an N, right? I'm only checking to see if this value is a lowercase n, right? Like you can pretty much type in anything here and it's going to keep going. Oh, and since it's using the next, it tokenized this input right on the spaces. But if I wanted to exit, I just put a lowercase n, press enter, and then finally I end the program. Yes.
Does it say that because you didn't give like a specification, like you only gave a specification for like n?
Right. Yeah. So that's exactly right. So I'll have to come up over here and maybe make like an if statement that says, okay, well, if it's y, then I want to continue. But if it's not y and not n, then maybe I say like that's not a valid input. Like try again, right? Like you can keep locking them in until they enter something that you expect.
It's like that equals case thing, or that method, or that.
Oh yeah, like when we're doing like rectangle and stuff, like if it doesn't equal.
Yeah, exactly. Yeah, like that. You'd have to come up with more conditions.
Where would you put that in there? Like before or after?
Well, right now this is kind of like a poorly written program because I have code repetition, right? Did everybody agree? Like I have the same statement there, have the same statements there. But what I could have done is like maybe like examine this a little better. I just assumed that, okay, I'm gonna grab the first chart no matter what. I should have probably just saved this off somewhere and then determine whether I should do something or not. I'll show you how to do that in the next one. Okay, so that is a while loop. Okay, now the reason why I'm gonna hop in the do loop is because exactly what I just said is since this is executed 0 to many times, there is a possibility that it might not be executed at all. The do loop, it's actually do while loop, it's guaranteed to run at least one time. So I can set it up in such a way to where I do not have this code repetition where I have the same statement there and same statements right here. Okay, so I'm gonna go ahead and make a new program. I'm gonna save this as do while demo, or was it loop? Yeah, do while loop. Copy that and save it as a Java file. So public class do while loop, and I'm going to say public static void main string array arguments. All right, and I'm going to use my scanner class. So I'm going to come over here and say import java.util.scanner. And then right here, I'm going to create my scanner object. All right, and then I'm gonna do the exact same game, but it's gonna be, I can write it a little cleaner this time because since I'm using a do, the syntax for it is this, do and then while. right? So the condition is down here. So it actually executes the statements at least one time, so guaranteed. So the execution is one to many times, right? So you're guaranteed at least one statement execution. So I'm going to have a control variable up here, and that control variable is going to be, I'll say in game. I'll make it game this time. And I'll say in game, and actually I don't really have to initialize this value right now because I'm not really going to use it until right here. So while I don't want it in the game, then I'm going to keep executing this loop. Now, normally Java will complain like saying you didn't initialize in game, but I'm going to initialize it inside of the loop or inside of this do because you're guaranteed to execute at least one time. I can do it inside of here. I'm going to say, let's see. I'll make like a guessing game, okay? So up here, I'm going to have an int. I'm going to say random number. I'm going to say my random number is equal to math.random times 10. Cast it to an integer plus 1, right? So it's going to be 1 through 10. Okay. And then I'm going to ask the user, let's see, system.out.println. He just print. Guess my number, and I'll say 1 through 10, or -1 to quit. Okay, so what I'm going to do is I'm going to say, okay, well, if actually I need to remember the user's input. Dang it. Okay, so I'm going to come over here. I'm going to make it and say user input. Okay. So the user input is going to be equal to scan.nextInt. Okay, and then I can do some if statements here. I can say, well, if user input is equal to -1, then what I can do is I know the user wants to quit, right? So then I can just say, okay, well, in game is equal to true. Okay, and I can say something like system.out.println. You chose to end the game. Okay. All right. Then over here, I'll say else if user input is greater than, let me see, is greater than or equal to 1, and user input is less than or equal to 10, that means that they have a valid input. All right. And then over here, anything else would just be like, that's not an option, right? And I'll bark back the number at them. I'll just say like user input, right? Whatever number they entered is not a valid option. All right. So I'm not really doing anything just yet, but I'm going to go ahead and compile and run. And I want to make sure that at least I handle quitting the game and putting in an invalid input. Whenever I have a valid input, I'm going to have to do a check to see if they guessed my number or not, or didn't guess my number. So I'm going to compile, and it's upset at me. Variable in game, oh, might not have been initialized. Dang it. I guess I do have to assign it a value up here. I'll say in game false. Compile and run. Okay, so guess my number, and putting like 1 through 10 and then -1 to quit. I don't like how nobody told me to put space after the quit. Dang it. Okay, I enter -1. I ended up quitting the game. Okay, that's good. Okay, now I'm going to enter in a value that is not valid. So I'm going to say, 100. Right, 100 is not a valid option, right? And then if I enter in a 9, which is a valid option, it doesn't tell me anything. It just, right? It came over here, and I entered a 9. It came over here, didn't do anything, but then the loop ran again because there is no condition to break out. All right, so let me put in a space right there. Now inside of my valid input, what I'm going to do is I'm going to check to see if the user input and the random number are the same. If it is the same, I'll just say system.out.println you guessed my number. I'll be excited about it with an exclamation mark, and then I'll just say like end game is equal to true, right? They just guessed it. You want to end the game. The else if condition would be user input is less than the random number. And if the user input is less than the random number, then what we're going to tell them is guess is too low, right? Guess is too low, right? And then the only condition left is being greater than the random number, right? So these are all valid inputs, so you don't really need an else if here. You could just do else, and then system.out.println guess is too high. All right, pretty straightforward, right? Pretty easy program to write. See how easy that is? Like you just do a little bit, add a little bit more, add a little bit more, right? Anyway, so this is actually a game that is actually going to work, and it's going to play like guess number between 1 and 10. All right, so I'm going to compile, and I'm going to run. Okay, so there is a random number that's been generated. I'm going to guess 5, too low. Okay, so then if it's too low, then I'll guess 7. Still too low. 8, too low. 9. Dang, it's really 10. Okay, I finally was able to guess the number.
How's that random number already generated? Doesn't it like a random number always keep going random?
You generate it one time and you save the value. Wait, what?
I thought like every time you use the method, it's like always a random number.
Oh, so I only used it up here outside of the loop. If I did generate it inside of the loop and that statement was getting executed every time in the loop, then yeah, it would be producing a new random number.
That would be like a slot machine game.
That'd be like what?
That would be like doing a slot machine game.
Yeah. Slot machine game. Oh, you're reading ahead? You're looking at all the...
I did that C++.
Oh, yeah, because there's a slot machine thing that you guys got to do as well in this class. But yeah, like this is just 1 through 10. We run it again, right? This time when I run it, the numbers should be different. It should be 10. I mean...
That random number is 1 through 10?
Yeah, 1 through 10 because I'm generating it right here with the math class. Okay, so this one I guess 10. It says it's too high. I'm going to guess 1. It's too low. I'm going to guess 5. I guess the number, right? 3 tries. And then the game ended. All right, so that's the way you use the do while. So the do while is probably, I think it's probably I don't want to say the best one to use. It depends on your situation, but you're guaranteed at least one loop execution, right? At least the first one. And then you have some type of Boolean condition that is going to determine whether you want to continue or not inside of the while. And as long as this is true, this do is going to keep executing over and over and over again. And I just used a bunch of if statements, which we just talked about that at the very beginning of the class to determine what I'm going to say to the user, right? I just nested a bunch of things inside of this loop. I actually kind of put them all together and make a program to play a game with the user, right? See how fun that is? Yeah. Really fun, yeah. So, all right. So let's go ahead and move on. There is another thing we need to talk about. The switch. I misspelled that. Nobody said anything to me. All right, so switch. All right. Okay, so the switch is almost like using the else or the if and the else, except it does has a very different syntax, and it only checks for equality, right? Like in the if statements, you can do like less than, greater than, but the switch only checks for equality. And let me just go ahead and make a demo of this really quick. So I'm going to make a new demo. I'm going to save it, and I'm going to call this one switch demo, and going to, yeah. All right, so I'm going to say, actually I'm going to use the user input again. So I'm going to say java.util.scanner. I'm going to spell it scanner. So public class switch demo, and then public static void main string array arguments. All right, I need the scanner. All right, and let's see, what do I want to do? I'm gonna make a char. I'll say user option. All right, and I think that's all I need. Okay, so the syntax for the switch is like this. You say switch, you're gonna examine something, and then you're gonna have case, and the case is going to be some value of whatever it is you're examining. This case, I'm using chars, right? And then you're gonna put some statement right here, some statement. And when you're done with the statement, you use the break to exit the switch, and then you can have another case, right? And the case is essentially just equality of it equaling something there, and then you can do like a break here, right, after you executed your statement, and then you can have a default statements here, and you don't need a break, but you'll just have some statement right there, right? So let me put this to use. So what I'm gonna do is I'm gonna make like a menu for the user. All right, and since the menu, I'm gonna make it look all nice. So I'm gonna make a bunch of stars. Dang it, I messed that up. Come back. It's supposed to go inside of the double quotes. Oh dang, what the heck? How did that happen? All right, man. Open, close, and then here I'll make the menu say like enter. I don't know. We'll make it like a. What? No, this is more like a menu of different options you can. Like I was thinking more like those old time RPG games where it's just there's no real picture, right? You're just talking to the computer, you know, like before you go to bed and you're lonely, you just hop on your computer and type in commands. So, just kidding. So I'm gonna say something like enter C to wait. Actually, this is supposed to be a role playing game, right? So I'll say enter A to attack, and then enter I guess R to run, right? Or maybe M to use magic. Then enter, let's see, R to run.
You have to have a jump in there. You have to really jump.
This is like those back and forth RPGs, so you don't really jump in RPG. Yeah, I guess you can heal, right? That's another thing. Enter H to heal. All right, so there's like 4 options there, okay? There's A, M, H, and R. So what I'm going to do is say, okay, well, I'm going to store the input inside of user option, which I declared as a char above all these statements. So I'll say scan.next.char@0. Okay. And char@0 is going to give me some char inside of user option. So I'm going to check for equality on user option. So case, if it is A, I'll say something like system.out.println. You chose to attack, right? Like you chose to attack. Okay. And I'm going to just copy this, paste, paste, paste. Okay, so I did A, I did M, I did H and R. Okay, so for M, I'm going to say you chose to use magic. This one, I'm going to say you chose to heal. And then this one, you chose to run. And the default would be like an invalid option. So we'll just say something like that's not a valid option. You entered an invalid option, I guess. You entered an invalid option. All right, save that. And I think we're ready to go. Let me see, compile. It does compile. That's always good. So run. All right. So here's my menu. I'm going to choose to attack. I'm going to use an A. I'm going to use lowercase a. I'm going to hit enter. It says invalid option. But what kind of RPG is this anyway? It doesn't recognize lowercase a. So I'm going to run it again. But this time I'm going to use a capital A. Okay. And you chose to attack. Okay. Now the reason why yes.
Could you use like the string uppercase method?
You could use that, or you can make another case over here that says lowercase. But I actually prefer the uppercase thing better, right? So this is actually going to catch capital A and lowercase a. So now when I save this, compile and run, right? If I enter in a lowercase a, then I chose to attack. If I run this again, it kind of sucks that I have to keep zooming in. Okay, run this again and I use an uppercase M, then I'm using my magic, right? You chose, but if I use a lowercase m, so I do prefer your suggestion where I'll just use the 2 uppercase right here. 2 uppercase. Compile, run. Now if I use a lowercase r, I will run. Right, you chose to run. And then you can, like I said, you can combine all this stuff together and I can have a do right here, slap it up there and come over here and dent all of that, make a Boolean called in game equals to false. Make this my control variable for my game. So it's going to go right down here. Wait, actually, no, that's the wrong spot. Right here. Okay. And while I do not want to end the game, I'm going to keep asking the user, what do you want to do? Attack, do magic, this and that. But I'm going to have a new case here for quit, to quit game. All right, so now I'm going to have to create a new case over here where Q is actually going to end the game, right? Let's say ending game. All right, and then I'm going to set in game to true. So the only way to end the game is to hit a Q, otherwise you can be stuck in this do loop, right? All I did was make a control variable, slapped exactly what I did inside of a do while loop, and I'm only going to end the loop if the user chooses to end the game by entering a Q. So now this game is actually going to continue until I decide, or till the user decides he wants to quit the game, right? So first thing I'm going to do is attack, right? Now I want to use some magic, and I want to keep using some magic, right? And then maybe I want to just type in a Y for yes. That doesn't make any sense, so it says you enter invalid option. I'm going to run, and then I'm going to heal my team, and then I finally getting tired of playing this game, so I'm going to enter a Q, and then you quit the game. All right, so I combine that switch for that I was using for a menu with a loop, and now I just kind of kept them in a loop where I can keep prompting the user over and over and over again until he gives me some value to where I can modify my control variable, right? This is my control variable, this Boolean variable right here, to be true, which would basically make not true false, and then the loop will terminate. Any questions on that? Okay, so that's what we're going to learn. So that means that all our programs are going to be super interactive now, right? So there is a homework that I'm going to give you from the book, obviously, right? I love giving students homework. But the homework in the book, I'm going to modify it. All the homework you're going to do from now on, there's going to be additional instructions on top of it. It's not just going to be do this problem from the book, right? So for instance, there is a guessing game, right? Exactly kind of like what I did, but 1 through 100. But I'm going to give you some specific details of how I want you to do it, because we're going to start using object-oriented program, meaning you're going to make a class for your game, and then you're going to make your driver have a loop, which interacts with your game object that you instantiated off the blueprint for a guessing game. right? So that's what we're going to do. Like the book is actually doesn't have you do all that stuff, but the whole point of this course is to enforce object-oriented design. So all your homework questions are going to have additional instructions on making your program object-oriented. Any questions on this? All right, so next class, we're going to jump into chapter 5. And then once I'm done with that, I should take like a week maybe, or at least 2 class periods. Then we'll get into chapter 6. And then the last thing we're going to talk about are arrays. So I think we'll probably be done with chapter 5 and 6 before Thanksgiving or right around Thanksgiving. And then after Thanksgiving, we'll just go over arrays, and then you'll be ready for your final exam. All right, that's all I have. Have a good night.